Imagine a machine so precise it can manipulate objects at the microscopic level, all built with open source components. Sounds like science fiction, right? Well, it's not. Meet the open source Micro-Manipulator, a project that challenges the notion that high precision requires expensive, proprietary technology. While stepper motors might not be the first thing that comes to mind for ultra-precise actuation, Diffraction Limited. Ingenious design proves they can achieve sub-micron accuracy when paired with clever engineering and external feedback. His creation, detailed on GitHub, https://github.com/micromanipulator stepper, is a testament to the power of open source innovation. But here's where it gets interesting. Instead of relying on the typical flexures, Hackaday.com/2019/0126 3D printed microscope stage offers precise movement. Hackaday.com/2022/0506 flexures make this 6DOF positioner accurate to the micron level for precision. This micro-manipulator uses a unique system of parallel linkages. Each linkage is driven by a crank attached to a stepper motor. But the real magic lies in the ball joints that allow for smooth, friction-minimized movement. The long linkage bars relative to the ball joints further reduce friction, enabling a remarkable 23mm range of motion in all directions. And this is the part most people miss. Achieving both precision and range requires closed-loop control. Diffraction Limited accomplishes this with a magnetic rotary encoder that divides a single rotation into a staggering 100,000 steps. But he didn't stop there. To push the resolution even further, he added an array of alternating polarity magnets to the rotor, effectively creating a magnetic gear that amplifies the encoder's sensitivity. The control system is equally impressive. A Raspberry Pi Pico 2 and 3 meticulously chosen motor drivers handle the actuation. Notably, the motor drivers lack internal charge pumps and clocked logic units, eliminating tiny timing errors that could introduce motion jitter. The double-sided carrier board uses through-hole components for easy replication and a thoughtful touch. The lower silkscreen displays pin numbers for added convenience. To put this micro-manipulator to the test, Diffraction Limited used it to position a chip die under a microscope with remarkable accuracy. He even traced a minuscule Benchy model, a common 3D printing test, within a 20 micrometer square, demonstrating a resolution of approximately 50 nanometers. That's precision on a scale that opens up a world of possibilities. From coupling optical fibers to lasers to exploring maskless lithography, https://hackaday.com/2023/44 assessing the micromirror device from a DLP printer for maskless lithography duty. Electrochemical 3D printing, https://hackaday.com/2021/0123 low-cost metal 3D printing by electrochemistry. Focus stacking, https://com/2019/12/30 focus stacking for tiny subjects, and micromachining, https://hackaday.com/2021/0109 micromachining glass with a laser very slowly. The potential applications are vast. Could this be the future of desktop microfabrication? Projects like the RepRap Micron, https://hackaday.com/2025/0822 RepRap Micron promises microfabrication for desktops with new prototype, certainly suggests so. But here's the controversial question. Can open source hardware truly compete with expensive industry-standard precision tools? While this micro-manipulator is undeniably impressive, it raises debates about accessibility, reliability, and the boundaries of DIY innovation. What do you think? Can open source projects like this democratize high-precision technology, or will they always remain niche solutions? Let us know in the comments.